So welcome back to another math video. So in our previous video, we started to look at trigonometric ratios. So what were trig ratios, the different type of trig ratios that are used, and we did some examples in finding an unknown side of a right angle triangle. So the focus for this video will be on finding a missing angle. So let's start by doing a little recap. So we know that trig ratios only work with the right angle triangle, and it's very important that you know how to identify the parts of a right angle triangle. So the longest side of a right angle triangle is the hypotenuse. The side that is opposite to the given acute angle is the opposite side, and the side that is next to the given angle or theta is the adjacent side. So the three trig functions that we use are sine, cosine, and tangent, and the trig ratios are sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. And an easy way of remembering it is using SOHCAHTOA. So let's dive into the questions. So the first problem that we have, it says to calculate the size of our angle H. So this is our acute angle right here, and we're given two of the sides. So just by having two sides, we can go ahead and find the missing acute angle using trig ratio. Sine equal to opposite over adjacent, cos adjacent over hypotenuse, and tan is equal to opposite over adjacent. So let's identify the sides of this right angle triangle. So we know that this is the opposite side, longest side is the hypotenuse, and this is the adjacent. So we see that the two sides involved are the adjacent and the hypotenuse. Therefore, we have to use cosine. So let's go ahead and find our angle. So cos theta is equal to adjacent over hypotenuse, and we're going to go ahead and substitute. So cos theta is equal to, so our adjacent side is 24, and our hypotenuse is 30. So when you are finding an angle given two sides, you have to use the inverse of the function to get the angle. First, we can first simplify this, or you can leave it as is and just do one thing, type one thing into the calculator. But I am going to go ahead and simplify that. So 24 divided by 30 will give us 0.8. So cos theta is equal to 0.8. So we want to get theta by itself, which is the angle. So we have to get rid of this cos. H is equal, so the angle theta is equal to the inverse of cos and 0.8. So we don't put, so you just type this into your calculator. So you press the shift or inverse button on your calculator depending on the type of calculator that you have. So shift cos, and you'll get the cos inverse, and you type in the 0.8. So you don't put a multiplication sign there, or you'll get error. So when we work that out, the given angle is equal to 36.86989.765, and we're just going to round that to one decimal place. So it would be 36.9, and don't forget to put your degrees. So here's our second problem. So we're asked to calculate the size of our angle X. So let's identify the sides of this triangle. So this is the hypotenuse, this is our adjacent, and this is our opposite. So we see that opposite and adjacent are involved, therefore we'll be using tangent. So tan theta is equal to opposite over adjacent. We're going to substitute our values. So tan theta is equal to, or opposite is 3, our adjacent is 6. And then we say to find, so you can work this out, simplify this, or you can just leave it as is. So to find theta, we say that we find the inverse of tan and multiply it by our fraction. So tan inverse 3/6. And you'll just be putting this into your calculator. Remember, you don't put a multiplication sign there. So theta, our angle x, is equal to 26.6 to 1 decimal place. Remember to put your degrees. Our final question. So the diagram shows 3 points which are on the same horizontal plane. So the longest side would be our hypotenuse. We know that, so this is our given angle, therefore this will be our adjacent side, and this is our opposite side. So the first part of the question says that we should calculate the distance from Walton Cree to Windy Crag and give your answer correct to 1 decimal place. So we're asked to find, so we're given the length of the opposite side and of the adjacent side. We don't know what the hypotenuse is. So can we use trig ratios? Yes or no? So no, we cannot use trig ratio. Do you know why? So we need an angle. So we need an angle. We don't have an angle. Our angle here is x. So therefore we have to use the Pythagoras theorem to find the hypotenuse. So using the Pythagoras theorem to find the hypotenuse, so the hypotenuse, let's say the hypotenuse is c, is equal to the square root of the sum of the two shorter sides squared. So c is equal to, let's substitute our values. So 5.2 square plus 6.8 square. And when we find the square of both of those, 5.2 square is 27.04 and 6.8 square is 46.24. So we're going to go ahead and add those together and we will get 73.28, and the square root of that number will give us 8.6 to 1 decimal place. And for it, remember to write a unit. So the hypotenuse is 8.6 kilometers. So let's go to the second part of the question, and it says that we should calculate the angle marked x. The angle marked x in the diagram if your answer correct to 1 decimal place. So let's use the two measurements that were given. So we're given the measurement for the opposite side and the adjacent, and we know that the trig ratio that deals with opposite and adjacent would be tangent. So tan theta is equal to opposite over adjacent. We're going to go ahead and substitute our values. So tan theta is equal to 5.2 over 6.8. Let's go ahead and find what theta is. So theta is equal to the inverse of the function. So tan inverse of 5.2 over 6.8. Plug this into your calculator and we'll get 37.4 degrees to 1 decimal place. So always remember, when you are given a right angle triangle, two of the sides, and you're asked to find one of the acute angle, remember that you have to use the inverse of the function, right? So you will look on the two sides that are given, and based on the two sides, if it is the opposite and the hypotenuse, and it's sine. If it is adjacent and hypotenuse, then it is cos. And if it is opposite and adjacent, then you have to use tan theta. So you would use the inverse of the function, plug it into your calculators, And remember to round off properly. Remember to put your units or your degree, and ensure that your calculator is in degrees, because if it is in radian or any other mode, you will be getting a different answer. So thank you for watching. Remember to like, share, and subscribe, and stay tuned for more educational content.